We're going to look at the role of the sympathetic nervous system, the effect of the renin-angiotensin system on control of glomerular filtration. Two of the chemicals have a strong effect will be angiotensin II and vasopressin. And what's the other term for vasopressin? Antidiuretic hormone. So how do these affect the glomerular filtration rate? The sympathetic nervous system will do two things. One thing it'll do, it'll activate the alpha receptors in the smooth muscle and cause vasoconstriction. So if you're running a long distance race, the sympathetic system is activated, secretes epinephrine or epinephrine. The receptors here cause vasoconstriction. What's unique with this is, remember, this is not autoregulation now. This is not autoregulation. That occurs, what is it attempting to do? Or what is it attempting to maintain? Blood pressure, blood volume. So you have to shut down urine loss to maintain blood pressure, correct? In the case of the sympathetic activation, the afferent arteriole is not nearly as much connected or affected as this one is. So in SNS activation, this is vasoconstricted, this is not. Therefore, I have to filter pressure. The pressure goes down here also. So what, if you're a long distance runner, what's one thing they find in the urine of long distance runners? Blood cells and proteins. Because if you reduce filtration, you start having glomerulonephritis, these cells die off, the pores open, and a lot of the proteins and red blood cells turn into the urine. That's only because if this shuts down, you don't maintain pressure here because this did not shut down. So you've lost that gradient. As we discussed earlier with the macula denser cells and the nitric oxide, both these are affected. So that although you have amount of fluid is less, you still have fluid going through. Here, you actually stop moving the fluid into the kidney. The sympathetic system also activates the JG cells to excrete renin. So you have a rapid response to decrease glomerular filtration and a long-term response to decrease filtration or water reabsorption, increased water reabsorption. Angiotensin II also has a vasoconstrictor response on the smooth muscle of the afferent arteriole, as well as vasopressin. So kind of in summary, how can renin be released? First of all, remember, it comes from JG cells, right? One way, it can be activated by the macula densa via the prostaglandins. They'll activate the cells to secrete renin. Direct innervation of the sympathetic nervous system will cause these cells to secrete renin. We'll hold off that one. So we look at the control of glomerular filtration. The primary control method is intrinsic, which we call autoregulation. The myogenic response and the tubuloglomerular feedback. That's extrinsic. Oh, these are both intrinsic. Remember, the intrinsic will maintain glomerular filtration rate at a mean arterial pressure of 70 to 170 millimeters of pressure, mean arterial pressure, around that. And does a very good job maintaining that, by the way. So as far as this text, all you need to know is the intrinsic consists of the myogenic, and the tubuloglomerular feedback. Tubuloglomerular feedback refers to the macular denser cells causing nitric oxide release and causing renin to be secreted from these cells. Okay, questions? Going once. Going twice. Okay.